Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about a full wave bridge rectifier with a resistive load. So friends, as we discussed in the earlier lecture, the efficiency of a full wave rectifier is 81% and the efficiency of a half wave rectifier is 40.5%. So which is very much clear that full wave rectifier should be used in many electrical applications and which is widely preferred over the half wave rectifier because of its efficiency. Now friends, let's talk about one more type of full wave rectifier and which is a bridge rectifier. So the main difference between a middle point or center tapped full wave rectifier and a bridge rectifier is in a center tapped rectifier we used to use 2 diodes, but in case of a bridge rectifier we will be using 4 diodes. So friends, let's draw the circuit diagram of a full wave bridge rectifier. So here we are going to use 4 diodes. So this is D1, D2, D3 and D4. So here friends, I am connecting a load resistor. Let's say VPT be the voltage across the primary supply and VPT is the AC voltage. And let's say VST is the secondary supply voltage or the voltage across the secondary terminal of a transformer. Now friends, if you can clearly see in this circuit, during the positive half cycle of the AC supply, diode D1 and diode D4 conduct. So the current flows through a clockwise direction. And during the negative half cycle, diode D3 and diode D2 conducts. So the current again flows in a clockwise direction. Now friends, if I just put a brief note on the conduction principle of the diode, we can clearly see that during positive half cycle, diode D1 and D4 conducts, and during negative half cycle, diode D2 and D3 conducts. But the direction of electric current is always clockwise during a full wave bridge rectification process. Now friends, let's see how the waveform look like for a full wave bridge rectifier, which is very much similar to the full wave midpoint rectifier with a resistive load. Let's draw the waveform of the secondary AC voltage. Let's say time with the x-axis and VST, I'm taking VST in the y-axis and VST be the secondary AC supply. Let's say this is 0, pi, 2 pi, 3 pi and so on. Now friends, let's draw the rectified DC voltage or the load voltage. As I've already explained that D1 and D4 conducts during the positive half cycle, which is this, and D2 and D3 conducts during the negative half cycle. So the direction is always clockwise. So the direction across the load or the voltage across the load never changes its direction because the current never changes its direction, which is always clockwise. So friends, here we have the rectified output DC voltage. Now let's talk about current. Let IT be the source current, then the waveform of the current will be somehow like this. It will follow the same sine waveform, but the peak value of the current will be less than the voltage because current is voltage divided by resistance. So now let's talk about how a load current or a DC current look like. So as you can see, friends, as the current flows during positive half cycle because of D1 and D4, and because of D2 and D3 during the negative half cycle, but the current flow during both the half cycle is same in direction, that is clockwise direction as per our circuit. So friends, here the load current will follow the same waveform as the load voltage, but the peak value of the load current will be less than the peak value of the load voltage as a factor of resistance. So friends, here is the waveform of a full wave bridge rectifier. So the mathematical expressions of the terms are same as the full wave rectifier with a midpoint connection with a resistive load connected across it. So friends, to summarize, the full wave bridge rectifier has an efficiency which is way better than the half wave rectifier, and we are using 4 diodes for a full wave rectification process, and 2 diodes conduct during the positive half cycle and the rest 2 diodes conduct during the negative half cycle. Ultimately, the direction of electric current is the same. That's the reason we are getting the rectified load voltage both during positive half cycle and during negative half cycle as well. So friends, thank you so much for watching this video. Please subscribe to Ekeeda and stay tuned with Ekeeda. Thank you so much.